The Monolith service we'll use for this demonstration is conveniently called Monolith. It's a service constructed using server-side Swift and the Katura framework, and it's like a simple Hello World service that also includes a basic login endpoint. I'll post the source code in the resources. Right now I'm looking at the folder which contains the Monolith project, its Swift source files, and the dependencies needed to build the service. We also have a Docker file which allows us to use a Docker container to build and run the Monolith service on a Linux system. The resulting effect of using Docker is similar to using a product like VirtualBox or VMware Fusion to stand up an entire virtual machine, but it's much more lightweight. Now, if you've never used Docker before, then I highly recommend you check out our resources on Docker before continuing. You'll also need to install the Docker engine and Docker command line interface, or CLI, and you can see that I already have the Docker engine installed and running because of its icon here in the top toolbar. Let's take a quick peek at the Docker file and see what kind of environment we'll be using. Here at the top of the file we see a Swift base image which is built on top of Ubuntu Linux. The next important section are where we install a few system packages that are required for building the monolith. Okay, let's go ahead and jump into a terminal session so we can build this image. Since the Docker image is already running on my machine, I can run docker build in the monolith directory to start building the image. In the docker build command, I'll pass the -t flag followed by the actual tag that I want, which for this image we'll tag it as S3 monolith version 1.0.0. And then if we specify the dot here, that means use the Docker file in this current directory. And once we enter this command, it'll start building our monolith. If this is your first time building the image, then it may take some time, but subsequent builds should go much faster. After the image is built, we can use docker run to create a container from the image. By passing the -v option, we can mount our local working directory for the monolith into the container. Everything before the colon is our local path, and everything after the colon is the path within the container. I'll pass the option --rm so that when the container exits, it's automatically cleaned up from our system. I'll pass the -p option to expose port 8080 so that we can send requests to the monolith. Like the -v option, everything to the left of the colon represents the port on our local system, and everything to the right of the colon represents the port on the container system. I'll also pass the --it option so that as soon as the container starts running, I'll be dropped into a shell session where I can take control of the container's command line. Finally, I need to pass a name for the image, and then the command to run as soon as the container launches. So for us that'll be /bin/bash that'll launch the bash shell. And that's my bad. I think for -it it should just be -it. So let's try that again. Great. You'll know you've done everything correctly if you can see a prompt like this one. At this point I'm shelled into the Linux environment and I can navigate to the monolith directory, which I'm actually already at. If we print our working directory, I'm in the app directory, and if I list its contents, we can see the same contents of the monolith directory that we have on our host system. So let's run Swift build to actually build this monolith service. Great. Once the build's finished, we can run the monolith. I'll clear the screen. Then we'll use .build, debug, monolith. Okay, so now the monolith appears to be running, and it's listening on port 8080. So let's open another terminal window and organize our workspace a bit. I'll put the window where our monolith is running here on the left side, and for the window on the right side we can make HTTP requests using curl. So in this right window, let's hit the base endpoint for our monolith service. We'll curl at localhost on port 8080, and we don't need to specify a path since this is for the root path, or the root endpoint. So this will make a GET request and return some simple JSON with a hello world message. Alright, now let's try the secure endpoint. And it returns nothing, or well, it returns that the authorization failed. This is because the secure endpoint expects a valid authorization token. So in order to get a token, we need to make a request to the login endpoint and pass a valid username and password. For this demonstration, I used some poorly named defaults. So for our username, it'll be -u and then immediately followed by username. And if we hit enter, when it prompts us for a password, it's just password. If we do this successfully, it returns a token that we can use for the secure endpoint. So let's copy this token. And then before we curl the secure endpoint again, let's pass a header value, and we'll begin with authorization bearer and then follow it by our token that we copied. And then before hitting enter, we need to specify our path, which is localhost 8080, and then secure endpoint. Now when we make this request, we actually get some JSON with our secure message in it. Nice. So these three endpoints, our base endpoint, our login endpoint, and the secure endpoint, they make up the entirety of the monolith. But even with this simple example, we can see we're using a microservice-based approach. We could split up maybe the token and then the message endpoints into separate microservices. And thinking big picture, this would allow us to decouple and more easily change how the token and/or the messages work. But before we do that, take a moment to make sure you can follow these steps, and then let's peek inside and see how the monolith actually works.